Alright, welcome back to the second part of the video on mole concept. Okay, so there's a total of 3 parts just to let you know. So in this second part, right, just do a quick recap. In the previous video, we actually talked about the first formula in this case, right? We talked about how to calculate the number of moles using the molar mass. Do you still remember what's the formula? Okay, as some of you can remember, the number of mole can be calculated if we take the mass of the substance in grams, okay, divided by either the AR or the MR of that substance, right? And that should give us the number of mole. For this video itself, right, what we're going to focus on is the second kind of equations, and that is to calculate based on the volume of a gas. So how do we go about doing this? Let's take a look at the notes. Now, in this part of the notes, right, you realize that we are taking a look at this thing called the molar volume, right? As you can see over here. Right, so what exactly is a molar volume? That's what you'll be asking, right? So let's take a look at this topic by first understanding that we can actually calculate the number of moles of a gas with use of this law known as the Avogadro's law. If you can recall, Avogadro is the person who found that 1 mole has actually 6.02 times 10 to the power of 23 particles, right? So he also found that actually as long as the gases have equal volumes under the same condition of temperature and pressure, they'll have the same number of particles. Now, what do I mean by that? Right? So basically what this guy found was that every 1 mole of any gas, any type of gas, okay, it will always occupy 24 dm cube of volume under room temperature and pressure condition, which sometimes we call as RDP. Okay? So this is what we call the molar volume, because it tells us the volume occupied by 1 mole. Of gas. Okay? Take note that this must only be used and it only behaves in this manner if we are talking about gas. Okay, that's why this entire notes we are looking at gases only. Okay, so for instance, if I give you a solid like magnesium ribbon, you cannot use the formula that you see over here. To help us visualize this, let's take a look at this particular slide. Oxygen balloon, a hydrogen balloon, as well as a carbon dioxide balloon. If all these 3 balloons at room temperature and pressure, they have the same volume. So for instance, if all of them have 10 cm cube, so this is 10 cm cube, this is 10 cm cube, this is 10 cm cube, same volume, right? So as long as it's 10 cm cube, same volume, by the Avogadro's law, it tells you that all of them have the same number of moles, because for gases only, right, as long as they have the same volume under the same conditions such as temperature and pressure, it will represent the same number of moles of substance. So let's go back to the notes and take a look at it. So before we move on further, now that we've mentioned that 1 mole of any gas occupies 24 dm cube, we must first understand what exactly is a dm cube, right? So a dm cube actually represents 1000 centimeters cube. Okay, so basically 1 dm cube is 1 liter lah. Okay, so because 1000 cm cube is actually 1 liter, so 1 dm cube refers to 1000 cm cube. Now, we always use dm cube in chemistry as a unit of measurements for volumes, be it gases or solutions, right? So sometimes you see cm cube, and which means that you need to be able to convert it back to dm cube. How does that happen? So every 1 dm cube is actually equivalent to 0.001 m cube. You realize that it has to be divided by 1000 in order to form dm cube, right? This is something that actually you are very used to already. Because let me just give you an example. Say for example, 1 km is how many meters? Yes, it's 1000 meter, right? So 1 km is 1000 meter. Then now if someone come up to you and say, hey, you change 20 meters into kilometers, how will you change? Okay, a lot of you will know very quickly that, oh, I just take the number and divide by 1000 lah, right? So correct, and it's actually equivalent to 0.02 km, right? Because like for instance, 500 meters is 0.5 km, right? 20 meters in this case is 0.02 km. So what you do is you divide it by 1000. Likewise over here, if we are looking at cm cube and change it back into dm cube, you also have to divide it by 1000 to form a dm cube. Okay, later we'll take a look at some examples. So, one of the first formula that we learned in the previous video was the number of moles is actually equivalent to the mass divided by mR or AR, provided that the mass is in grams. Today, we're actually learning a new formula, okay, which allows us to calculate the number of moles, but using the volume of gas in dm cube divided by this magic number known as 24 dm cube. 24 dm cube is what we call the molar volume. Right? How much volume will the gas occupy? How much volume will 1 mole of the gas occupy at room temperature and pressure? So taking the total volume of the gas, maybe it's 48 dm cube for example, divided by 24 dm cube, you end up with 2 moles of substance. Let's take a look at some examples. Alright, so let's look at the question. I need to find the number of moles in this volume of gases. So now, knowing that it's gases, right, actually I should straight away think of this formula. Mole is equivalent to volume of gas in dm cube divided by 24 dm cube. So let's take a look at this. Sulfur dioxide. Okay, sulfur dioxide, the formula is SO2. Although it's not important in this case, just to let you know, the formula is SO2. How do I find out how many moles is inside this 1.2 dm cube of sulfur dioxide? I can apply the formula, which tells me that mole is equivalent to the actual volume now. It's 1.2 dm cube. I'll divide this by 24 dm cube, which is the molar volume, and that will give me 0.05 mole. So this tells me that inside 1.2 dm cube of sulfur dioxide, I'll be expecting only 0.05 mole of sulfur dioxide. Let's look at the next example, question 2. What if you have 24 cm cube of methane? Now, if you have 24 cm cube of methane, of course this is a gas also. The formula is actually CH4. It's a gas. It is something you must know. So knowing that it's a gas and you're given volume, one way to find the number of moles is to use the formula that we just learned. Mole equivalent to volume divided by 24 dm cube. But can we just take this 24 and sub it into this volume? Yes, some of you might have noticed you can't do that because this volume must be in dm cube. Right? So I have to first change. So 24 cm cube, do you still remember how to convert it into dm cube? How do I change from 24 cm cube into dm cube? Yes, I divide it by 1000, and that will give me 0.024 dm cube. So the number of moles is actually equivalent to 0.024 divided by 24, right? And that will actually give me a value of, you can use a calculator to key in, and it will give you a value of 0.001 mole. Right? So you notice that it's a matter of familiarity. Once you get the hang of it, you should be able to do it by yourself. Okay, maybe you should try out question 3 by yourself so that you have a hang of what you are supposed to do. Your teachers will actually go through it with you when you come back into class. Now, let's take a look at part 2. Part 2 a little tricky because it's a little more complicated. What do I mean by that? In part 2, right, if you read the question carefully, you realize that they're asking you to find mass of the volume of gas. Okay, so same thing, just for information, chlorine gas actually Cl2, the formula. Okay, this is a formula for chlorine gas. Now, the question wants you to find mass, but they give you volume, right? So I need to think of how can we go about calculate this thing. Okay, if you think about it for a second, right, there's 2 equations that you learned today. Number 1, mole is equivalent to mass grams divided by mR or AR. The other one that you learned today is actually mole is equivalent to the volume of the gas in dm cube divided by 24 dm cube. Right, these are the 2 things I learned today. Now, if you look at these 2 formula, I actually want you to find the mass of the substance, right? But I also give you the volume of the substance instead. Now, how do we find out what's the mass of the substance? If you think about it for a second, to find out the mass, right, you need to take the mole multiplied by the MR. Am I right? Right, to find the mass, you need to use the mole multiplied by the MR. MR is something you can find from the periodic table. Because chlorine can be found in the periodic table, you can use this. But this mole is here unknown because you don't know what's the number of mole. Correct? But think about it for a second. Actually, using the second formula, right, you can actually find out what's the number of mole. Yeah, sorry, the arrow will be ugly. You can find out what's the number of mole. So, the mole of the chlorine gas is actually equivalent to is 480 cm3 of chlorine gas right now. So you can use this volume and divide it by 24 dm3. Okay, but of course we have to change this into dm3. How do we change it into dm3? You divide it by 1000 and you end up with 0.48 dm3. So 0.48 dm3 divided by 24 dm3 will give you the number of moles. And that's actually equivalent to 0.02 mole. Now, am I right to say that this 0.02 mole is the amount of chlorine gas there is? Which will mean that you can actually use it over here. Am I right? You see how I just combined two equations together to solve this problem sum? Right. What you must understand over here is that now the question is actually giving you cm3, which is the volume, but they're asking you for the mass, and there's no way that you can just use one equation to solve this question. So always convert the value into mole first if possible, as you see over here. Then using the mole, help yourself to find out what is the mass, which in this case is 0.02 multiplied by the MR. How do you find the MR? Same thing, let's go back to the periodic table. Chlorine is over here. Okay, the AR for chlorine is 35.5, right? But in this case, we are looking at Cl2, which is chlorine gas molecule. Okay, and that means this mass, this MR that you're looking at over here is also times 2, because there's 2 chlorine, right? And this will actually give you the mass of the chlorine gas, which is 1.42 gram. Right? So with that, you realize that you are actually able to solve the questions by combining the formula together. Now, what have we learned today? The first video that we watched previously was to tell us that what is the number of moles based on the mass of the substance, right? And the AR or MR. Then we went on to say that, oh, actually there's another formula that you can use by knowing the volume of the gas and divide by 24 dm3. There are some questions that actually requires you to combine them together to do a bit of changes here and there so that you can solve it. So in this chapter, right, it's really a matter of whether you understand what you're trying to do rather than just trying to memorize every single step. So of course with practice it will become better. So with that, what we need to do, right, is to go back, complete up and 3 like what I mentioned just now. This part 3 by yourself. And of course all these questions at the bottom where you're asked to try yourself. The reason is because in this topic, practice really makes perfect, and it helps you to fine tune what are some of your careless mistakes. Your teachers will go through all these answers with you when you're back in class. With that, we have come to the end of the second video. Thank you.